This video is about the science behind the Wim Hof Method and is based on an interview of Rhonda Patrick and Pierre Capel.
Some of Wim Hof's methods of breathing, and he does some cold shock. I've been very interested in the effects of good types of stress on the body. So we've been talking about bad stress, chronic stress, but there's also eustress, good stress.
Oh, absolutely.
So maybe we could dive in a little bit, because I know that you're very interested in some of the mechanisms and the science behind how cold and how these certain breathing techniques can change different hormones, the endocrine system, immune system.
Oh, it changes a lot. The point is that, first of all, Wim Hof is a very charming man with a lot of stamina and a lot of charisma. And he really knows how to talk to people to convince them that they have to do what they think they should not do, like going into an ice bath. Everyone who just thinks I'm going into the ice is a little strange, but he convinces, please do it. And the weird thing is that people like it and get a positive effect. And then you say, hey, how, why? Well, if you go unprepared into ice cold water, 0 degrees Celsius or whatever it's in Fahrenheit, you have a lot of pain, you get a lot of trouble, a lot of anxiety. It is terrible. Don't do it. However, Wim is training people and they do it and they like it. What is the training? The training has two components. First of all, a meditation type of thing. So you really have to come at ease and really try to get rid of all the surrounding stress. And then do this breathing technique. The breathing technique itself, you do about 20 minutes, is a type of meditation in itself, but also a breathing technique. So why not have a double-edged sword? And this breathing technique, he really specialized in such a way that you change the content of carbon dioxide in your blood and you lower it. Carbon dioxide is acidic in water, and if it's out of the bloodstream and the tissue, or at least less, then the pH is less acidic but more alkaline. In the normal situation, the acid-alkaline balance, which is called pH, the strict balance is pH 7, and our body is 7.4. That is our regular situation. In the stomach, it's very acidic, and in that is this. So there is a little difference in the body, but let's say 7.4, that is our body equivalence of alkaline and acid. By this breathing technique, and pumping out a lot of carbon dioxide and having periods in not breathing, heavy breathing, and he can tell people how to do. You change your pH. And now comes the little trick that in his training, that type of breathing raises the pH sometimes to 7.7, 7.8. And for biology, that is a lot.
Yeah, and this is published.
And it is published. It's scientifically measured and whatever. But we go now back to this terrible cold. If you go, you always have an idea of the temperature of your surrounding, and for that you have a whole family of receptors, thermosensors, and there's a whole family, and for each temperature range you have a separate set of family members who are telling you what the temperature is. So if it is above 50 degrees Celsius, rather hot, you will burn. So if you touch something which is very hot, immediately you can't react differently. You can't keep it on and say, it smells. You don't. But if it is 37 degrees, you say, nice. And so there is, for each temperature range, is a family of temperature sensors, which are proteins which are doing things. And they do not only measure temperature, but also mechanical stress. And so if you feel something, this touch, you feel, hey, it's metal, it's colder, it is this. That is this whole family of things. One of the family members is effective beyond 17 Celsius, so cold. And because our body temperature doesn't want to be lowered, this cold surrounding is aggressive. We should avoid it. So you get an active stress response, get out of the cold and now. That is this receptor telling you. However, he is not alone. Because if you go in this cold water, it's painful, it hurts. And you get a very strong anxiety response, and I have to get out, and that's so dominating that it really can cause you a lot of trouble, heart attack. So if you go into ice cold water, and you are really in trouble. The body is telling you that. However, pain, anxiety, and temperature, they are all combined in this skinny dipping in the cold water. But biologically, they are separate units. And normally, the thermosensor tells you it's cold, and his job of this thermosensor is telling you, hey, switch on the heat, burn your brown fat, generate calories like hell, make energy in temperature should not drop, so burn everything we have to keep your body temperature constant. That is the function of this receptor. But it is coupled to a pain receptor. So you cannot just sit in the water and say, oh, nice, I'm changing my metabolism. You have pain. But now we come to the pain receptor, which is another one. And there's also a family of receptors. And the trick is this. It is a protein in the membrane, and as a single protein, it's doing nothing. But if 3 of these proteins combine into a trimer, so three proteins together in a certain conformation, then they will signal, and that signal is pain. Normal situation, like we are sitting here, let us say that 5% of our pain receptors are in an active state. So if I do this, well, I feel it, but it doesn't hurt. However, if I have a big wound here and I do this, then we get trouble with the neighbors because I shout too loud. Because then this not 5% is on, but everything is in the trimer position and generates a pain signal. So a pain signal has a volume switch. Can be low, can be high. But it is dependent on a lot of things, also inflammation, but also on pH. And at pH 7.7, the pain receptor is a monomer.
So
it's out, so no pain. But the same receptor is also in the amygdala, giving fear and pain, but also in the spinal cord and all over your body. So all of a sudden you don't feel pain, don't feel anxiety, but the temperature receptor, which normally gives you pain, is doing now the job by himself only, generates an incredible amount of adrenaline, gives you energy you won't believe, burns your fat like hell, and Wim Hof is able to sit for 2 hours, or 1 hour and 58 minutes, or something like that to be precise, in ice cold water without a significant change in body temperature. Why? Because his thermosensor is heating up and burning the brown fat. Come on, boys. And afterwards, you're going to change the white fat into brown fat, which is, the brown fat is in this area of your body. And so you regenerate that. And so if you come into the cold, you get a fantastic amount of energy. You get this strong stress response without pain and fear. And then you can walk up a mountain in short time.
What's the name of the thermoreceptor? Do you know? The name
yes, that is transient potential, TP.
Oh, one of the TPV or RV?
TPV, there's a whole family.
Okay,
I'm always
so
bad in names.
It's responding to the cold. And
there are also receptors which are responding to heat and whatever.
Right, yeah. So I have so many questions, but one is the importance between coupling the breathing technique, which then decreases the carbon dioxide in the blood and as a consequence raises, right, but it raises the blood pH to a little more alkaline, which by the way is not easy to do. Usually you can't just raise your pH of your blood, but breathing, obviously the breathing techniques, obviously sure. it's working and that's been published. And that then switches off the pain receptor, which needs to be trimerized. So it's now not able to do that because the pH is too high. Yeah. So that's uncoupling now the pain receptor from the thermoreceptor, which somehow I know that UCP1, the uncoupling protein, which norepinephrine, which is cold, releases norepinephrine, and that activates uncoupling protein 1, which then uncouples your mitochondria. So your mitochondria usually are sensing, the electrochemical gradient, and when that becomes uncoupled, your mitochondria go, oh my God, I need to make energy, so they're burning more, you're basically burning all the energy, like you said, to, generate heat and to also make ATP, energy, ATP, so you end up burning fat, like you said. This is all really cool because I was, for one, the pH, changing the pH of the blood, I was a little skeptical of that until I actually read the study and how carbon dioxide in the blood can do that. I think there's a term for it, like respiratory alkalosis or something. Oh yeah,
like that. You can name it whatever. Yeah, but the point is, it's functional.
Yeah. Have you tried any of the breathing techniques or?
Well, no, not in that sense. But I have a little story. I know a guy who was doing this for the first time, and he didn't take this breathing so serious. So I said, well, I said, okay. And in the meantime, wandering around, and then hopped into the cold water, and that was extremely unpleasant. And then the second time, he really was aware, hey, I should take it serious, this breathing. And then he had no trouble. So this is a control in itself. So the breathing technique is really necessary to prepare for this cold. And this cold will, after uncoupling of all the other effects, will have the positive stress response in metabolism, adrenaline, etc.
Without the pain. So you can withstand the cold for longer.
Yes.
I've been very interested in the effects of temperature on the human physiology. I've talked a lot about the sauna and how the sauna is a good hormetic stress, activates heat shock proteins, which have a variety of positive effects. It also changes brain function as well. It changes the opioid system, endorphins, makes you more sensitive to them. So I became very interested in that. But cold, more recently, I became interested because there was a paper that was published in Nature last January where researchers took mice and exposed them to about 4 degrees Celsius for 45 minutes. Caused their core body temperature, so unlike Wim, their core body temperature dropped from 98.6 to about 65 degrees Fahrenheit. So very hypothermia almost. But what was very interesting is that the cold shock, there's a whole class of proteins called cold shock proteins that are activated by the cold. And one of them specifically is in the brain and at the dendritic spine region of neurons. And it increases dramatically in the cold. And what's really interesting is that what the function of this protein is RBM3. is to regrow lost synapses. So hibernating animals, bears, for example, some hibernating rodents, when they go into hibernation, they lose a significant amount of their synapses. I forgot, like 30 or 40% or something like that. But when they come out of the hibernation, they regrow the synapses that they lost, which has huge implications, of course, for neurodegenerative disease, brain aging in general. So this is kind of what instigated the study, because they found that what happens is upon hibernation, they have this huge increase in this gene in the brain, RBM3, and that regulates, regrowing the synapses. So that's when I became very interested in the cold, and then started reading about it and all the effects on the endocrine system, norepinephrine, burning of the metabolism. And now I'm very interested in some of the techniques that Wim's doing and the science behind what's going on. So I'm really excited to have you talk about it. And but you wanted to talk about a couple of other interesting effects on the same family of receptors.
Yes. And then we don't go so bizarre as in the heat or in the cold or whatever, but we just go to this family of receptors, which the family name is TRP, and then you have Uncle M and Auntie V, and so the whole family is RTPV1 or M, etc. The question is that you have a measurement of each type of temperature by each family member. But now the question is, why in the tropics people eat so spicy? A lot of hot peppers. The point is this, that a compound with a beautiful name in the red pepper is binding to one of these family members, which senses heat. Not the extreme heat, not the 50, but so around 40 degrees Celsius, or so around 100 Fahrenheit. What it's doing, that the pepper stimulates this receptor, so the receptor thinks you are too hot.
Capsaicin, is that specifically?
Yes,
yeah.
That is the name. But the receptor senses, hey, it's hot, and is reducing your body temperature to neutralize the effect of the outside temperature. So you lower your body temperature by spicy food. But if you're in the tropics, you will be heated up by the sun. And if I go as a Westerner, I like spicy food, but if I haven't done it and walk there, I'm sweating, and then you have this really white man's burden in the tropical, you know that, well, sorry. But whereas if you have spicy food, you lower your body temperature, the sun is raising it, but to the normal level you want, and you don't have to sweat to get rid of the extra temperature because you set your thermostat lower. So that is what the hot pepper is doing. Now the other way, the cold receptor, if you have a cold, you have all these type of things that you wrap your breast with menthol or eucalyptus, etc. The point is that compounds from these plants bind to the cold receptor. So as soon as you rub in your chest, it feels cold because you sense cold, like the pepper, you feel hot. But that temperature receptor is not only making more energy and whatever, but changing the blood flow. So the blood flow increases in this area where you put menthol or eucalyptus, and you generate heat. So first it's cold, and then it really is getting warm because you pump up the fire by this plant extract. And the trick with cold, why it's so good and very simple, and you don't need further medication because you can do it yourself, is what is a common cold? If I am for 10 minutes outside and unprotected and I feel cold, tomorrow I'm ill, how is that possible? The point is that this illness is already there, but I can cope with it. So you have a rhinovirus or whatever cause of my common cold, and my immune system is coping with it. So let's say I have 100 units of immunity, which have to fight to 80 units of a viral or whatever infection. So the immune system dominates the infectious agent, and this is a continuous process. Now I go 10 minutes into the cold, the blood flow changes because the cold gives vasoconstriction, so you have less blood. So my 100 units per time can't reach that place and become 75. Hey, says the virus, poof! And because that goes very fast, half a day or a day later, you have a common cold. So if you now put on some menthol or eucalyptus, by increasing the blood flow and giving a lot of energy and raising the temperature, then the immune system comes back with much more units per time than the 100 and can cope with it. And so therefore these simple things from plants have a very strong effect.
I never knew there was actually any validity behind putting menthol or eucalyptus oil.
But you're feeling cold and warm and...
I don't remember, like, you know, it's been so long. I was a kid. I think my mom put it on my chest when I was sick, but it's been decades since I've done it. So I don't remember feeling warm.
Well, you can do it now.
Maybe, kind of a burning feeling.
Yeah.
So, okay, let me ask you this then. Why when you go out in the cold, don't you have the same response? So obviously there's vasoconstriction occurring. How come there's not a response then also similarly to then increased blood flow after? Or is there?
Well, the point is that if you go into the real cold, like Wim is doing, you switch on full-blown all the engines to pump up the fire. But if I walk out here and I go from room temperature to a little lower, I don't have this family member which is reacting at minus 17. My throat is getting minus 24. So I don't activate the receptor Wim is using, which pumps up the whole thing.
Oh, I see.
And I do with menthol, I go to the low temperature receptor, which I pump up the activity. So a decrease in temperature from 37 to 28, so in your fingers it can be 28 or so, that doesn't switch on the receptor which Wim is using in the cold bath. So you have to go much further. So if you go into the ice bath, you immediately trigger the subsequent response. If you just walk outside and you're just chilly or whatever, you do not have the proper family member of the receptor being activated.
Mm-hmm. So we need to also be happy when we go outside when it's cold, because being happy also regulates our response to this virus and whether or not we're going to fight it off.
Okay, yeah. And so it is really important to have a positive view on life. And there are a lot of studies of people who are optimistic or pessimistic, and that really makes a difference statistically in how they cope with diseases, life expectancy, the number of days without disease. That is directly related to a positive or negative attitude to life.